Hi guys, you're welcome back to the channel. Today we'll be talking about encryption and decryption using Python. So in basic terms, encryption is the process of converting normal messages into meaningless message, basically the encrypted form that nobody will be able to guess what message is contained inside this particular meaningless form, so to say. So, whereas decryption is the process of converting meaningless message to its original form, which is the like original message. So, the original message is referred to as the plaintext, while the meaningless or the encrypted form of the message is called the ciphertext. So, there are so many. This is a very important topic in modern day technology with the wealth of delicate information needed to be exchanged between systems. Some examples of this message include, say, credit card information, access tokens, username and passwords, banking information, and so on. So, for you to encrypt data, you're going to be needing a key. Let's just get into it. For you to encrypt data, you're going to be needing a key. So, let me zoom in to make it okay. So for you to encrypt data, you're going to be needing a key. So we are going to be discussing two different algorithms for encryption. The first one is the symmetric key encryption, while the second one is the asymmetric key encryption. Now, for the symmetric key encryption, it is less secure. You need a single key that is going to contain the message. All you have to do is to encode your message inside the particular key. You send the key out to the receiver. The receiver will decrypt the key, will get the message. But anybody that finds the message can just decode the message and go away with the information. And don't forget, these are vital informations that this is vital information we are talking about here. So let's get into the symmetric encryption type of encryption. So we are going to be using a Python library called cryptography. Okay, so cryptography is a Python library that you can use to do symmetric key encryption. So the first thing you want to do is to install it using pip. This works in VS Code as well. I'm using Jupyter Notebook just for this particular tutorial. It works in VS Code, whichever one you want to do. So do pip. You can go to your terminal, pip install cryptography. But since I'm in Jupyter Notebook, I have to put in this to show that I'm trying to run a terminal command. So I have to wait for it to install. I think it's already installed in my Jupyter Notebook, so I can just walk away, but it's still running, so I just have to wait a bit. Okay, I think it's done now. So now that cryptography is installed, I can start to run my algorithm. So in this cryptography library, there's a particular class called fairnet. Fairnet is what we're going to be using for this particular kind of encryption. So let me do a bit of labeling here. Symmetric encryption. Okay, so this should be, the type is going to be markdown. Okay, so okay, for the symmetric encryption, the first thing you want to do is to import the fairnet class. So from cryptography dot fernet, you want to import the fairnet class. Okay, so after importing the fairnet class, let's create a message. Basically, let's say the original message equal to, let's say, let's create a username, say Marcus Mark Pellegrini. Then let's say a password, just some string combination and all that. Okay, so this is the original message that we want to encode. So the next thing you want to do is to generate a key for the encryption. Don't forget, I said you are going to be needing a key to do encryption. So, and for this particular type of encryption, you need only one key. So you generate the key now. How do you generate the key? You say key equal to fairnet dot generate underscore key This is a method inside the finite class. Okay. So now that you've generated your key, the next thing you want to do is to instantiate the finite class using that particular key. Okay. So what we want to do now is to create, let's say, fnt equal to finite. Then you pass in the key as an argument. Then the next thing you want to do now is to do the encryption. So for you to do the encryption, all you have to do is to create a variable, say encrypted message. Okay. Now this encrypted message is going to be equal to your finite, which is basically fnt. Don't forget you've instantiated your finite with this key over here. So fnt dot encrypt encrypt. Okay. So encrypt. Then you pass in the message, which is the original message. But you are going to be encoding the message. So by default, Python strings have this method, the string class called encode. So encode, and voila, your encryption is done. So let's see what the encrypted message looks like. Encrypted message. Okay. So you can see what the encrypted message now looks like. See what the meaningless message looks like. Don't forget, this is the message that we are trying to encrypt, to encode. We are trying to encapsulate this data over here now. So after encrypting it, this is what we get. But how do we decrypt this message now? If we want to see the content of this is a meaningless message, how do we decrypt it to show the original message? All you have to do is very simple. All you have to do is just say fnt. This same fnt class over here, don't forget, you have instantiated it using this key that you generated over here. You understand? So you've instantiated it. So with this same fnt class, you're going to be doing the encoding and the decoding. So to decode the data now, all you have to do is to say fnt.decrypt. Then you pass in the encoded message, which is the encrypted message. Pass in the encrypted message. Then after passing in the encrypted message, you call the class decode. So let's say we are going to be saving this into the encrypted message. Okay. So for this decrypted message, let's show the decrypted message. Okay. So to show the decrypted message, no, this should be decrypt. Sorry about that. Okay, you can see Mark Pellegrini, and the original message is Mark Pellegrini. You can see the password, and you can see the password. It doesn't necessarily have to be username and password. It can be any kind of data at all. It can be credit card information. It can be whatsoever. Let's try to use another message over here. So let me say credit card information. Let me see if I can get something from Google. I can copy fake credit card details. Okay, so fake credit card generator. Just give me something. Generate something. Okay. I think this should do. So this is the credit card details that I'm trying to encode. Okay. So let me just paste this here. You can see it's a Visa card. This is the PAN number. This is the expiry month, the expiry year. So let me make this 07. So to make it easier, or let me just leave it the way it is. So 592. Okay, so now to encrypt this particular message, all I have to do is to just run the same algorithm. Let me comment this one out, okay, to make it neater. So if I'm running this, you can see this is the meaningless message, the ciphertext. Like I said, this is the ciphertext. So this is the plain text over here. For me to decrypt the encrypted text, all I have to do is just to run this function again. Don't forget everything. Yeah, I'm using Jupyter Notebook here. On your end, if you are using, say, VS Code, you have to print. You have to print. Don't forget. But let me just, to make it simpler, let me print as well. Jupyter gives me the advantage of just, okay, so you can see everything is intact. I've not lost any message at all. You can see. You can see. So that is how you do symmetric encryption. But like I said, this is not. This is less secured. I won't say it is not secured. It is secure to some extent, but it is not very secure because you are using this same key to do the encryption, and you also have to use this same key to do the decryption. So anybody that has this key basically can just come from nowhere and get your message because the message is contained in this key. So now, how do you do asymmetric encryption? How do you do asymmetric encryption? The asymmetric encryption is done in such a way that you have two keys, the public and the private key. So the public key is what you are using to create the encryption. So the private key is used to decrypt the message. So you can send the public key out, but only the system that has access to your private key can decode the message inside. So let's get into it. Let's say asymmetric encryption. Okay, but this is going to be a markdown. I don't think you'll be able to do this in VS Code. Well, there's a way to do it, but just take your eyes off this one. I'm just trying to use it for simplicity. So to continue, don't forget to like the video and subscribe to the YouTube channel to help us with the YouTube algorithm so more people can get access to the video. Also, when we post content like this, you get notified on via your device. So thank you. We proceed now. Now to do asymmetric encryption, it's very simple. We use two keys. One will be the private key, the other one will be the public key. Like I said, you use the public key to encrypt data. The public key is sent out to the receiver. The private key is what you use to decrypt the data. This is the reason. This is one major advantage it has, making it more secured. So the algorithm we are going to be using here is called the RSA algorithm. So for you to implement this algorithm, you first of all have to install the RSA library. For you to install the RSA library in Python using pip. So on your VS Code, or you can open a terminal or whatever. So in my own case, I just have to pip install RSA and I'll run it. Okay, it is collecting RSA now. Okay, I think it's almost done. I think it's installing now. It's almost done. Okay, I think it's done. So, to proceed, the first thing you have to do is to import the RSA. After importing RSA, the next thing you want to do is to generate your keys, which is the public and the private. How do you generate it? So we are going to be using something called tuple unpacking here. Tuple unpacking. Let me just create a new cell to explain what tuple unpacking is. If I have x, y equal to a tuple of maybe 2, 3. If I should run this, x is going to be taking 2 and y is going to be taking 3 automatically. So this is called tuple unpacking in Python. So it's what we're going to be using here to destructure what the RSA is going to be generating for us. It is going to generate the key by itself. All we have to do is just to save one as the public, then one as the private. Okay, so all you have to do is just public, comma private. Okay, so equal to RSA dot new keys. You're now passing 512 as the argument. So then you write the message that you want to encrypt. Message equal to, which is the, let me just say this as the original message. Okay, let me generate another fake credit card. Let me use this one. It doesn't necessarily have to be a credit card information you're trying to encrypt. Any kind of information at all, so far it can be represented as a string. Okay, so this is the original message over here. Now the next thing I want to do is to encrypt the message. I have my keys, I have the message. The next thing to do is to encrypt. Okay, so the encrypted message will be equal to, the encrypted message will be equal to rsa.encrypt. Encrypt, CRPYT. Then you're going to be passing in two arguments. The first argument is this original message. Then the second argument is going to be this public key over here. But this original message, you have to encode it. You have to encode it. So encoding the message says dot encode. Okay. After encoding it, comma public, and your message is encoded. Now let's try it out. Don't forget, this is going to be the plain text. This is going to be the plain text. Now to generate the ciphertext, now let me print the encrypted message. Okay, running this, you can see what the encrypted message looks like. So this is the encrypted message. Meaningless, but it contains this particular information over here. So you're going to be sending this to whomever is going to be receiving it. Do you understand? So this is going to be the encrypted message. And this encrypted message was generated using the original message after encoding it and the public key generated over here. But for you to now decrypt this particular message, you are going to be needing the private key to decrypt it. Now decrypting the message, all you have to do is to say the decrypted message will be equal to rsa.decrypt. decrypt. Okay, decrypt. No. Okay, so now you're going to be passing in two arguments. Don't forget, for you to encrypt, you are using the original message and the public, but for you to decrypt, you are going to be using the encrypted message and this private key over here. So basically, you copy the encrypted message and the private key. Then you call the decode method. So to make it neater, okay, I think this is fine. So now to now show the decrypted message, print decrypted message. Okay, voila, you can see this is Visa. This is 4024, exactly the message I encoded. Exactly the message I encoded. So it works fine. Let me try to use another string. Let me say YT administrator. Then password can be any combination of strings. Maybe ID is maybe 54. Okay. So for me to encrypt this message, I have to just run this You can see what the encrypted message looks like. You can see what the encrypted message looks like. Now, for me to decrypt the message, just run this again. Shift enter, and you can see YT administrator. You can see the password I entered, the ID, and whatsoever. And you can see the space bar. No information is lost at all. So these are two ways you can encrypt and decrypt data using Python. It is it's a very useful skill to have when working on softwares, on websites or systems where you have to share vital information. You have to keep your users as safe in the internet space as possible. So thank you very much. I'll see you in the next video. Don't forget to like the video and subscribe to the channel. I'll see you in the next one. Bye for now.